Hi everyone. Let us discuss electromagnets. Objective: at the end of this video session, you will be able to prepare and check the electromagnetic. What is an electromagnet? Before discussing electromagnetics, let us know about magnets. Magnets are solid objects that exhibit a force called a magnetic field. That force attracts iron particles when brought closer to the magnets. A rock or chunk of metal that has the power to attract specific kinds of metal is known as a magnet. Magnetism, often known as the magnetic force, is a fundamental force of nature just like electricity and gravity. Magnetism is a long-range force. This indicates that an object can be pulled by a magnet even when it is not in contact with it. Magnetism happens when tiny particles called electrons behave in a certain way. All objects in the universe are made up of units called atoms. The electrons spin around the atom's nucleus, which contains the other particles. The spinning electrons form tiny magnetic forces. Permanent magnets are some kinds of magnets that can pull on items by themselves. Lodestone, sometimes referred to as iron ore magnetite, is a naturally occurring permanent magnet. By applying a magnetic force to specific materials, one can create more permanent magnets. These materials maintain their magnetic characteristics even after the force is removed. Magnet properties. Magnets strongly attract objects that contain iron, steel, nickel, or cobalt. Magnets also attract or repel, push away other hard magnets. This happens because every magnet has two opposite poles or ends, a north pole and a south pole. Other north poles attract the south poles of other magnets, but they repel other north poles. Likewise, south poles attract north poles, but they repel other south poles. The magnetic force between the two poles of a magnet creates a magnetic field. This is the area affected by the magnet. A magnetic field surrounds all magnets. History of magnets. Magnus, a shepherd from Magnesia, Greece, made the initial discovery of magnetism. In the mountains, Magnus was leading his sheep by the neck. He suddenly realized that the nails of his sandals were attracted to a rock along with the ferrule of his stick. His stick and nails, which contained iron, were drawn to the magnetic rock. The stone was named magnetite after the name of the shepherd it was found. It was also known as a lodestone because of its magnetic properties. Application of magnets. One of the earliest uses of magnets was in compass. A compass is a needle-shaped magnet that is free to turn around. The planet Earth is a giant magnet. Because the south pole of a compass is attracted to the north pole of the Earth, the compass needle always points north. Today, magnets are found in many places. Magnets hold papers on refrigerator doors. They also hold the doors shut. Credit cards have a magnetic stripe. Let us move on to the electromagnet. As the name implies, the magnetic property occurs when an electric current flows through a conductor. When an electric current flows through a conductor, it creates a magnetic force around it and loosens the magnetic property when electric current is stopped. When the conductor is crowded together as a coil, it will behave like a magnet. In 1824, William Sturgeon, a British physicist, created the electromagnet. His initial electromagnet was a horseshoe-shaped wrap of iron that had 18 turns of naked copper wire wrapped around it. Electromagnets play a vital role in electrical machines like motors and generators. Motors and generators always require magnetic force for their work. Controlling magnetic force is only applicable in electromagnets and not in permanent magnets, which is why 80% of motors and generators use electromagnets rather than permanent magnets to control the speed and induced EMF. The amount of magnetic field depends on the current flowing in the conductors. So, by varying the current in the coils or winding, the magnetic field can be controlled, and by controlling the magnetic field, the parameters of motors can be controlled. The strength of the magnetic field depends on the number of turns in the coil and the current flowing in the coil. Furthermore, increased current flow results in increased magnetic fields. Properties of electromagnets. An electromagnet is temporary in nature. An electromagnet is made of a soft iron core. The electromagnetic field strength can be changed. An electromagnet can be easily demagnetized by switching off the current. The polarity can be reversed. Applications of electromagnets. Engineers create electromagnets, a fundamental component of motors. Magnetic motors are widely used in both businesses and factories as well as in daily life. We employ a number of motors to make our lives easier, so we may not even be aware that we deal with electromagnets on a regular basis. Refrigerators, clothes dryers, washers, dishwashers, vacuum cleaners, sewing machines, garbage disposals, doorbells, computers, computer printers, clocks, fans, car starters, windshield wiper motors, electrical toothbrushes, electric razors, can openers, speakers, music or tape players, etc. are common examples of electronic devices that use electromagnetic motors. Electromagnets are employed in the medical industry as well. The MRI scan, also known as magnetic resonance imaging, is a tool that makes use of electromagnets. Using electromagnetism, the device can scan every single feature of the human body. Let us discuss about solenoids. Solenoids are a type of electromagnets, produces magnetic field only when the current flows in it, else no magnetic field is produced. The solenoid's purpose is to provide a nearly uniform magnetic field similar to the magnetic fields produced by permanent magnets. Magnetic fields produced by permanent magnets are constant and challenging to vary, making solenoids more convenient to use for a variety of purposes. What makes solenoid different from a magnet? Solenoids are simple to turn on and off as needed because they depend on an electric current source to function similarly to a magnet. Secondly, by altering any one of a number of variables, the magnetic field it generates can be changed. Let us discuss how to prepare a simple electromagnet. Take a PVC pipe with a 25 mm diameter and 100 mm length. Fix the PVC washers at both ends of the PVC pipes to prepare a bobbin. Make 4 holes in PVC washers for 2 mm using a drilling machine to take the lead out. Secure the lead out wire. Start the winding over the bobbins using enameled copper wire of 16 SWG. Complete the windings by taking a tap at an interval of every 200 turns, 200, 400 and 600, such that the common and 3 terminals are taken out through the holes provided in the sidewall PVC washer. Insulate the top layer with an adhesive insulation tape. Fix the electromagnet on a 150 mm into 300 mm wooden board using a plastic saddle. Connect the drawn-out ends with sleeves to the 4-way terminal fixed on the board. With the help of the knife, carefully remove the enamel at the end of the conductor, including the tappings, for 1 inch without damaging the conductor. Set the multimeter to continuity mode and check the continuity by placing the probes at the ends of the conductor. Connect the ends of the solenoid to the 12-volt battery through switch S. Close the switch. Note the soft iron piece is pulled by an electromagnet due to magnetic force. From this video session, I hope you will be able to prepare and check electromagnetic property. Thank you for watching. Have a good day.